Okay, thank you everyone for waiting. So we are now going to start the keynote speakers too. So we will have the same moderator as before. So Mas Gio, let's invite him. Hello, Mas Gio.
Hey everyone, hope you're not get tired with me.
Okay, so Mas Gio, the stage is yours. So let's welcome Sebastian Ramírez. See you.
Okay, thank you, Dima. Thank you everyone for attending this session. I think we'll also have another very special person who will be joining us in this session. So Sebastian Ramirez, I think like everyone in the group, everyone in the Python community, most of you already know about Sebastian. Sebastian has been building at least two very famous framework. One is the FastAPI and the other is the Typer, which is like the very important building block when you're building application, right? One is for the API and the other is for CLI application. So Sebastian is hailing from Colombia and currently living in Berlin, Germany. So without further ado, let me invite Sebastian to the stage. Okay. Hello, Sebastian.
Hello everyone. Thank you for inviting me.
Hello. How was your flight last night to Indonesia? I'm just playing make believe. I assume that we're already free from COVID and you can actually come to our country and speak in front of us.
Well, the flight was great, a bit long, but
Okay, so maybe you can actually tell a bit about the title that you're going to talk about today in the session.
yes, I'm going to tell you about modern Python through FastAPI and friends. So a little bit about type annotations, well, a lot about type annotations, a little bit
Nice.
about async and await, and some of the friends.
Okay, okay. You're also going to be talking about the type hints, right?
Yes.
Okay, that's very great. Okay, sure. I think are you ready now for the presentation?
Yep. Sure.
Okay, sure. Please, the stage is yours. Okay.
Thank you. So, okay, I think you can all see my window, right? Excellent. Let's go. So we're going to talk about modern Python through FastAPI and friends. So first, who am I? I'm Sebastian Ramirez, or Triangulo. I live in Berlin, Germany, but I am from Colombia in South America. That's why the accent. You can find me on all the social links, GitHub, LinkedIn, Twitter. I'm currently a staff software engineer at Forto, which is a company in San Francisco that is doing machine learning over and like natural language processing and artificial intelligence to improve the area of customer experience. And I'm also an external consultant for other teams. And I created FastAPI, Typer, and SQL model. That's why I'm here today. So we're going to talk about modern Python. And when I say modern Python, I'm talking about the currently supported versions of Python, so 3.6 and above. We're going to talk a little bit about f-strings, a bunch about type annotations, a bit about async and await, a bit about performance, community, and we are going to do that through FastAPI, Typer, SQL model, and all the friends and all the building blocks. So first, a little bit about FastAPI, for those of you that might not know. So FastAPI is a Python framework, a web API framework that has high performance, it's easy to learn, it's fast to code, and it's ready for production. It currently has a bunch of GitHub stars. People have been liking it. It seems it's currently used by Microsoft, Uber, Netflix, and a bunch of other companies. And the performance is in the top rank of what you can get with Python. So that's why I'm here, because I created this FastAPI. So let's start talking about modern Python. A little bit about f-strings. Many of you probably already know, but still, let's do a quick recap. So let's say that we have this data structure. We have some recipes, and each recipe has like some particular ID, like Crunchy Frog or Albatross, and then it has some ingredients. In the case of the Crunchy Frog, we have a bunch of things here, and for the Albatross, it's just an albatross, which is just a bird, so that's the only ingredient. And we have a default price. Then we have this function that is going to receive the name of our recipe and the quantity, and then it's going to return some data about this recipe. Perfect. And if we call it, we say, hey, get me the recipe for this particular ID, and then we get this information, and it says, okay, the total is 1. And if we say, get me the recipe for the same ID with a specific quantity, then we get a different total, and we get all the information that we were returning. Now, if we check a little bit closer, here in the message, we are currently, we are sending this string here. And if you see, this string has these curly braces with this keyword here, this name here, and then we use the format method in the strings. So we are repeating name here, and then here, and then here. We are saying name 3 times here. We're duplicating some information here in the code, and we can simplify all that by just putting an F at the beginning of the string and say, hey, here in this point, put the name, and then Python, by using this F, which makes it an F string, will take this name from the environment. So from this parameter, from the variables that are outside. That's the whole thing. That's the whole trick. But and if we call it, it just works as we expected. But now, instead of having a bunch of complex stuff that is repeating and duplicating, we can have simpler stuff. That's it. Now let's jump to type annotations. We talked a little bit about F strings. Now let's go and talk a bit more about type annotations. So now, let's say that we don't like the response, the message that we get saying, hey, here's the recipe for crunchy dash frog. That's the message that we are currently getting. Let me go back a little bit to show you that. So we are getting, hey, this is the recipe for crunchy dash frog. We don't want to have that. Let's go forward again. We want to have crunchy space frog, and we want the crunchy and the frog to be in capital letters. So let's just modify the string. But when we try to do that, we try to hit to get auto-completion from the editor. We don't get anything because the editor doesn't know what name is. So we don't have any auto-completion. We just have to, by memory, know what are the methods that we need to call to be able to do that transformation that we want to do on the string. But we are totally fine without completion and type checks because we have lived all life without them, right? But what if we change just this little thing here? Instead of just putting name, we say, hey, the name is of type string. This is the standard way that we declare in Python, hey, this is the type of this variable. It's not necessary in Python, but it will help us a lot because it will let the editor help us with auto-completion and inline errors. So we say this, and now we suddenly have auto-completion inside of the function. So the editor can tell us, like, can help us guess what are the things that we need to call. So now we can just replace that dash for a space. And because the editor knows that the result of this is also a string, we don't have to put another colon string somewhere here or something. The editor already knows that this is a string, so the editor keeps giving us auto-completion. So we can keep triggering auto-completion and then have auto-completion and type checks for everything. And then we have the final string here, and then we can just like use it, and with a lot of help from the editor. Now, if we call it, then everything just works correctly, and now we're getting the crunchy frog as we wanted it, like a title. Nice. Now let's say that we want to do another little refactor. We don't want everyone doesn't necessarily want one quantity of the thing, of the recipe. Maybe some people want just the recipe alone. Not necessarily they want it served. They just want to have the data of the recipe. So we can just easily change it. Instead of having a quantity of 1, we can say that quantity now by default is none. And it looks like a simple change. But then when we run that and we don't set a quantity, we get an error after running that code. And the error says, hey, you cannot do this multiplication here, multiplying an int with none. And it's because here the default price that was an integer is being multiplied by quantity that now by default is none. But the thing is, we had to run that code to be able to get this error. We didn't have any help before running the code, and that's the annoying part. Now, what if we tell the editor, hey, this is the type of this parameter. We're saying, hey, quantity will be an integer, but like the value that this can have is an integer, but by default, it's none. And just by doing this, the editor already can help us a little bit because it will detect and it will say, hey, you're doing something. If you're telling me that this will be an integer, but by default is none. So this can be an integer and none. You are using it this in this line, you're using it incorrectly. We can see the error right here before having to run the code. And when we check the error, it effectively says, hey, you cannot multiply an integer with none. So the editor is helping us avoid a bug that we will have to wait until we are running the code in production to finally see. Just because the editor knows what are the types of these variables. So these type annotations, these type hints are just protecting us from a bunch of bugs that never have to hit production to be able to see it. So that's great. Now, let's refactor this and let's fix this. So instead of returning the data, we can just create the result here. And then we check if quantity is not none. So quantity can be none, but it can also be an integer. So if it is not none, it means that quantity will be effectively an integer. If quantity is not none, then we are going to use quantity and we are going to assign it to the result. So this is what we do here. Perfect. That will solve the problem. Now, if we check, we still have this little error here, this little squiggly red line. What does that mean? Let's see. So the thing is that we are not telling the editor, hey, this result is of this particular type. So the editor is trying to guess what is the type of this result, the editor or the tooling that we are using. And in this case, it's guessing that it's a dictionary that has as keys strings and as values strings or lists of strings. So it's expecting to have a sequence of strings at most. And we are passing it an integer. So it's saying like, hey, this is not like the same type that I'm assuming this dictionary has. But then to fix it, we can just tell it, hey, don't try to guess too much. I want to tell you, this is just a dictionary that has any type of key and any type of value. It's just like a simple way to tell it, relax a little bit. This is just any dictionary. And then the editor will say, okay, if it's any dictionary, then I will receive any value here. And now we don't have this quickly line error. This means that we don't have to add these type annotations to every variable because the editor will infer what is the type of many of these variables. We just have to put them mainly in the parameters of the function and it will guess most of the rest. And when it doesn't guess things correctly, we can just specify explicitly, hey, this is the thing that I really intend to have in this variable. And if we see, we are here, we're telling it, hey, this quantity is of type integer, but by default is none. And the editor is smart enough that it knows that it can be an integer, but it can also be none, even though we are not really saying this can be an integer or none. We are just saying it as the default value. And it knows that at this point in the code, it can be an integer or it can be none. But when we check inside of this block, this if block, this if block is checking if quantity is not none. So inside of this if block, quantity can only be an integer because we already discarded the option of it being none with this if. Inside of this block, the editor knows that it can only be an integer. So the editor is smart enough to know there is one type here, but it's just it's like a combination of the union of these two types here, but it's just one possible type inside of the if block. Now, we can be a little bit more formal and we can say, hey, quantity is an integer, but by default is none. It's actually like counterintuitive because this can actually be none too, not only integer. So we can be more formal and import from typing import optional. Typing is a standard module in standard Python. So it just comes with Python. And this is the standard way to tell Python, hey, this could be an integer, but it could also be none. And we use, instead of using parentheses, this is not a function, we are using square brackets. And we use these square brackets a lot when declaring types in these type annotations. So now this is the formal way, and we can be a bit more explicit about what we mean with this quantity. And with type hints, we get all this help from the editor with the auto completion and with the inline errors. But without type hints, we will have to be on our own. But it's just like a little bit of extra annotation, and then we get a lot of help from the editor. Some of the people that are behind these type hints. these guys, they created, they are the one, like this guy created MyPy, and they are the maintainers of MyPy, which is the main tool to check these type annotations. And it existed even before they were part of Python, and then they were integrated into Python. But I wanted to show you that this is just like normal people that are building these things. It's just like a few people, in many cases, that are building all these things that give us a lot of benefits, and they are just like helping others. Now, let's switch a little bit, and now let's talk about type annotations with FastAPI. So let's say that we want to make this whole function that we had, we want to make it an API. So we just have to import from FastAPI, import FastAPI, then we create an app object, which is an instance of this class FastAPI, and then we decorate that function using the app object that we created. And we are telling it, hey, whenever you receive, hey, FastAPI, whenever you receive a request, an HTTP request that is using the get operation or the get HTTP method, and it goes to this path in the URL to slash recipes slash, and then this next thing, this is going to be a path parameter. So slash recipes slash anything, you extract that last part, does anything, as this name variable, and then put it in the name parameter here. And then I want this function to be the function that handles that request. So we added 3 lines of code, and now we have a full API for the same thing that we had before. So the more FastAPI code you write, the less API code you write, because FastAPI tries to get out of the way as much as possible, and then you can focus on the business logic of your application. And because it's all based on type annotations, of course, we get auto-completion in all the code internally. And we can be happy as this cat. And we also get error detection, because again, this is just like type annotations, standard type annotations. FastAPI uses this information that we are declaring here, these type annotations, to extract the information from the request. And it also gives us an automatic API documentation user interface. So if we start the server just with that code that we added, those 3 lines, and we go to /docs, then we will get this user interface in the web browser that tells us, hey, whenever there's a get request that goes to /recipes/name, and this is a path parameter, this is the interface that we can use to see what are the information that we can send. In this case, the name is a required path parameter, which is a string, so we can pass it here. And there's a quantity that is not part of the path, so FastAPI will read it from the query parameters. And we declared that it was an integer, so it will make sure that we are sending indeed an integer. And if we try to send some data and we click that execute button, we will get this back, which is the message that is being returned by the web server that we created with FastAPI. And this is not like an example that is saved somewhere. This is run live, communicating live to the server and getting the response live. So we can interact with the API that we are building right away while we are building it. This can help a lot when building APIs and debugging. And we can see that we are getting the message that we say that we were going to receive. So FastAPI is converting that automatically to JSON and getting us all the information. So we write some basic code, and good guy FastAPI makes a docs user interface for you. Now, it also does data validation. So remember that we added in the quantity, we say that it could be none or it could be an integer. If we try to send something that is not an integer, in this case, this is actually a string. We are saying 9, but this is a string. In this case, the same documentation user interface won't even let us send this string because it's not an integer. But even if we would try to cheat and we send it through the command line, and we just send, hey, here's the quantity that is 9, then in the query parameters, then we will receive an error that looks like this and says, hey, in the query parameters, in the parameter quantity, the value is not a valid integer. So FastAPI is doing data validation for us, for the data, just based on the type annotations. So without valid data, FastAPI will protect our code from running with broken data. So whenever our code is being run with the type annotations that we declared, FastAPI is giving us certainty that that code will run with those type annotations that we declare. But if the types, because it's doing all the validation for us, but if the data is valid, then it will just run and will just execute as we expected. And FastAPI also does data conversion. So if you check this quantity, which is a query parameter, it will go here in the URL. This will be the URL that we will use. Slash recipes slash, and this crunchy frog will be this name. And then this quantity, this is part of the query parameters. This quantity will have a value of 2, which is this 2 that we are sending. If you check closely, this quantity, this is part of the URL, and the URL is just a long string. So this 2 is actually just part of the huge string. It's just a string. But FastAPI will convert it to an integer, and then in our code we will see an actual integer. It will not be it will not be a string that contains the number 2. It will be just an integer with the number 2. We can confirm that because the total that we're receiving is actually an integer, and it's multiplying an integer with an integer, so this is working correctly. And this is all based on standard type hints. FastAPI is also based on standards, on OpenAPI, JSON schema, OAuth2, and because these standards and because all this, we can get automatic API documentation. This documentation that we get is provided by this tool called Swagger UI. And Swagger UI doesn't even know that much about FastAPI. It knows about OpenAPI, and then FastAPI connects with Swagger UI to show this using OpenAPI. So this is all the things that we get, because this is just based on standards. And because it's based on type annotations, on standard Python type annotations, we get auto-completion in an errors, but also with FastAPI, we get automatic data conversion and automatic data validation, apart from this automatic documentation. Now let's change to Typer. So let's use type annotations with Typer. So Typer is a tool to building command line interface applications. And as you can see, it's very similar to FastAPI. We just import Typer, we create an app again, and then we decorate a function with this app object that we created. We are telling Typer, hey, I want you to create a command with this function. And now we are not returning some JSON data or something, because this is just a command line. So we want to print it on the screen. Then we use typer.echo. So this is just a little bit of Typer salt. And now we get, with that, we now get a command line interface application. If we run Python, main.py, let's say that our code is in main.py, then we get this automatic help. We get an automatic help menu, and it's already doing data validation, telling us, hey, there's a missing argument name that you need to use here. And if we pass the name, then we get the message that we were expecting. It's printed on the screen. And we also get automatic extraction of command line interface options, like this quantity that in FastAPI will be extracted from the query parameters. In Typer, it will be taken from these options that are called with dash dash something. So we can pass quantity to, and then it will do also the data conversion and convert these to an actual integer. What happens if we send invalid data? Let's say that we send quantity 9, the same that we were doing with FastAPI. We also get data validation, and it's telling us, hey, quantity is not a valid integer. And with Typer, we also get tab completion in the shell. So the final user will get tab completion in the shell, so auto completion. Whenever they start writing an application, in this case, I created this application that is also called Typer, and then they hit tab when they are typing some option or some command. It will auto complete the rest of it, which helps saving a lot of time. And with that, we are just like already building CLI apps with Typer, just with the same type annotations. Now let's combine Typer with Rich. So Rich is this great tool for displaying information in the terminal, and also for some types of interactions. And Typer and Rich can be combined very well together. So we just import some tools from Rich, for example, this console. And then we create a table that we are going to add each one of the ingredients to this table, and then we're going to print that table, and then we're going to print the total. So this is just like a little bit of extra code. And now when we show the information, we get this nice display of our information in the command line. So Rich and Typer are great combined together for building command line interface applications. Some of the people behind the scenes. Typer is all built on top of Click. Click is what does all the actual work to read all the information from the command line interface. This is the maintainer of Click. And Rich was created by Will, which is also improving a lot Rich because he just went full on open source and is creating Rich and a bunch of other things for the command line. So this is, again, just normal people that are doing all the work behind the scenes so that we can benefit from all that. Now let's switch to type annotations with FastAPI and Pydantic. So FastAPI is based on top of, built on top of Pydantic. So we can use Pydantic to create the data that we want to declare, that we want to receive in requests. In this case, we are creating a food class that inherits from base model. Then we say, hey, then it should have a field that is name, that is a string, and it should have ingredients, which is a list of strings that by default is just an empty list. So this list comes from the same typing that we were using before. So this is not something particular to Pydantic. This is, again, the standard way to declare that something is a list in Python. And we're saying, hey, this is a list of strings. And next we use this same class food, we use it in the parameters here in the function. And we're telling FastAPI, hey, this function will receive a parameter food, which is an instance of this class food. This is the standard way to say that some parameter, some variable is an instance of a class. And then FastAPI will make sure that we actually receive an instance of this, and then we can access those attributes that we declared, like food.name or food.ingredients. This class, the way that we declare this class is very similar to how you will declare data classes, for example. And when we go to the documentation now with this Pydantic data, the documentation knows what is the shape of the data that we want to receive. It knows that we want to receive a name that is a string and ingredients, which is this list. And if we try to send some data, we try to interact with it, we will get effectively the response as we were expecting, just communicating live with the server that we created. Now, what happens if we send invalid data? So this is all valid JSON, and the name is a string, and ingredients is a list. And the first ingredient is a string. So up to now, all good. But the second ingredient, this ingredient is not a string. This is a JSON object or like a Python dictionary. And as you can see, the invalid data here is deeply nested inside of this whole data structure. If we send it like this, then we're going to receive an error. FastAPI will give us an error automatically that says, hey, in the body, inside of the ingredients, in the index 1, because index 0 will be the first element, in index 1, a string type was expected and is not what we received. So we're getting like all this automatic data validation, even for deeply nested data structures that we can create and that we can define however we want using the standard type annotations. Now, what happens if we want to have nested data? Let's say that we don't want to have a single food item. We want to have orders, which is a list of orders of food. Again, we just use the standard type annotations to say, hey, this will receive a list of instances of food. And because now FastAPI will make sure that orders is a list, we can iterate for each one of those food orders. So if we want to have JSON and we want to have it inside of JSON, we can declare that however we want. We just use the standard type annotations with Python and FastAPI. And because this is all based on the same standard type annotations, we get autocompletion for free everywhere. If you see, this is a double nested for loop, and it's knowing that ingredient is a string and it's giving us autocompletion for ingredient. It knows that because ingredient is part of this ingredients list, and it knows that the ingredients list is a list of strings, and it knows that food comes from these orders, and food will be an instance of this food class. So we just declared type annotations in the standard way, and now we get autocompletion even for these deeply nested data structures. And we can have autocompletion everywhere, even for our own code. And we also get error detection because it knows what is the type of each one of these parameters and these variables. So it knows that ingredient cannot be added to an integer because ingredient is a string. Some of the people behind these things. So Samuel Colvin is the creator of Pydantic. Tom Christie is the creator of Starlet. Starlet is the building block of FastAPI. FastAPI is built on top of Starlet and Pydantic. Pydantic does all the data part, and Starlet does all the web part. And David Montagi is a notorious contributor, so there's a mention here. But again, this is just normal people working and trying to help others, so others can benefit from all that work. Now let's combine this a little bit, FastAPI with SQL Model. So SQL Model is this library for interacting, combining Pydantic and SQL Alchemy for interacting with SQL databases. So we create a model that is very similar to Pydantic. We tell it, hey, I want this to be a table in the database. And we say, hey, the ID will be an integer, and this is a primary key, name is a string, secret name is a string, and age is an actual integer that by default is none. So age will be can be none in the API, but it will also be in the database. It can be null in the database. So we are using the same type annotations to declare the data that will go in the API and in the database. Then we can just create an engine, and then we can create the data from the database when starting the application. And now we can create, for example, this function that will receive post requests and will receive a hero object, and will just save that hero object to the database. Now, the thing here with SQL model is that each model is both a Pydantic model and a SQL Alchemy model, which is the library that goes underneath doing all the SQL stuff. So we can use the same model for the type annotations, for doing the data validation and all that stuff. And then the same object is ready to be used with the database. And we can just like save it to the database, and then we can just return it. So we can use the same object in all the places that we will use for the database and for Pydantic for data validation. The same, if we want to return a list of heroes, we can use the same type annotations and say, hey, this is a list of heroes, and we can just return the same object that we get from the database directly. And because this is all based on Pydantic, FastAPI will be able to extract all the information from this and give us like all the results right away. And if we go to the documentation, because each one of those models is also a Pydantic model, we get the automatic information extraction from this data that we declare even in the documentation. So we can have database and data models without duplication of all the information in one place and the other. Now, some of the people behind these things, Samuel Colvin, the creator of Pydantic, and Mike Bayer, the creator of SQL Alchemy, which is the tool that does all the SQL work behind the scenes in SQL model. Now, a little bit about more Python with async and wait. So now we're switching completely from the topics. So with async and wait, what is the deal? Python is actually very fast when you compare it to the network. So the main problem is that the network is very slow. If the network is the part that is slow, how can we improve that? So a simple idea will be, let's have multiple clients talking at the same time with the same backend that is written in Python. That way, these multiple clients can, even though the network will be slow, at least all of them can be talking to the Python backend. So that's a great idea, but in reality, when we write the code like in a simple way, then this is what will happen. We will have a list of clients that is just waiting, a line of clients that is waiting for the one that is on front to finish their request, to finish their transaction, before each one of the previous ones can start interacting with our backend. So this one will have to wait until this person on top passes, I don't know, the toilet paper or whatever, and buys them and pays and packs them before this person can start trying to buy his newspaper. So it will look more or less like this. We have a client that is sending a slow request through the network. Then Python will process it very fast in comparison to the network and will send the response. And then the response will go back through the network slowly until it reaches the client. And then the other clients will have to be waiting until this response reaches the client before they can start their own request. Of course, this is just like milliseconds, but when you have a lot of clients waiting and they will have to wait for each other, then the last client will have to wait a lot. And that is the whole point. So the API app will be just waiting for the network to finish. So here's the idea. What if we have something like a waiter that can go, we can have the client sitting at their tables, and the waiter goes to each one of the tables and asks them, hey, what do you want? What do you want? What do you want? Takes all the orders, then sends them to the backend or to the kitchen to be prepared, and then brings the orders back. That's what we get with async and await. It's like if we have something like a waiter that is here, part of Python. So this is just like internally of Python. And it will go to the first client, hey, what do you want? And the client will start checking the menu. This will be slow while the client is deciding what to get. Meanwhile, this same waiter can start asking the next client, hey, what do you want? And then the next one, what do you want? Maybe this one will be my sister that is taking a long time to decide what she's going to drink. So the waiter can just continue with the next client and ask the next one, what do you want? Then it will keep receiving those orders and sending them to the rest of our code, and our code will be preparing orders all the time. So the main point here is that the Python code that we wrote will not have to be just waiting, just sitting there doing nothing, not using the CPU, just waiting for the network. It will be constantly doing stuff, constantly using the CPU, because it will always have some order to prepare. Because async and await, like this waiter, is making sure that we already have some work to do here in the kitchen, in the backend. That's the whole trick. How does it look like in real life? So, for example, we're combining FastAPI with HTTPX, which is this amazing library for interacting with HTTP servers or APIs or whatever. And now with FastAPI is actually asynchronous underneath, so we can use these async functions. And once we use an async function, inside of the async function, we can continue using things like async with, like this, to create a client. And then we can use this await. This is the whole point. This await part here is where we tell Python, hey, the next thing, this part here, this could be my sister that will take a long while deciding what she's going to drink. So this might require waiting some time. So you, Python, might want to go and help another client while this thing is done. This is what this await keyword here means. For this to work, this method get will have to be declared also using async, which is the case with HTTPS. So to use async and await, we need to use libraries that are compatible with async and await. But then with this, we can get like all this additional performance and additional concurrency. So we can help a bunch of additional clients with the same code. And if we use it in the web API, it will just look the same and we will just get the same response. Like everything will just work as normally, but now we can serve a lot more clients at the same time. Now, async and await, because we need to have libraries that are compatible with both async and await to be able to use async and await. And sometimes we cannot just like use it everywhere, because like if we try to put await in something that is not compatible with await, then it will just break there, or it will just like break the way that it works, and it will be just like a waiter waiting in the kitchen to have some plate instead of serving the other clients, things like that. But with FastAPI and HTTPX, for example, they are compatible with both, with async and with non-async code. So we can just declare a normal function, and then we internally can just use HTTPX directly without using any await here. So we can also do that. This way, we can write the code as you have been writing it normally, or even like migrate any code that you might have, and it will just work. Because what FastAPI does here is that it runs this code in a thread pool so that it's not blocking the main event loop. That's the technical detail, but it's not like you don't have to know the technical detail. The thing is that you can then use also normal functions that call normal code internally that will be blocking, without having to use async and await. And then in the cases that you need to optimize the performance, then you can go and use async and await for those cases with compatible libraries. So with FastAPI and HTTPX, you can use both normal def and async def. Even in the same application, you can have some URLs that go with async and some that go without async. Some of the people behind these things: Tom Christie, again, he's the creator of Starlet, HTTPX, and more. One of the commentators of HTTPX, the creator of the specification that powers these async things underneath. Again, just people helping others. Now, with FastAPI, we get performance that is on the top rank of Python. This is a benchmark that is run by a third party called TechEmpower, and they compared a bunch of different languages with a bunch of different frameworks. In this case, I'm filtering, showing you only Golang, Go, the compiled programming language, with Python. Go is the green lines, Python is the blue lines. And Go has to be a lot faster than Python because Go is a compiled language, so it better be faster. But as you can see, with FastAPI and a bunch of other frameworks here, we can get on the ballpark of Go, and we can get even faster than some of the Go frameworks, which is great. Because like we don't have to change the programming language that we are using. We can get all the benefits and all the productivity that we can get with Python, and still get a very good performance in terms of concurrency and throughput. So in terms of the amount of clients that we can serve at the same time, which is great. Which one of these is the fastest? That has some noise here because, for example, Ubicorn is the server. This is not even a framework. It's the server directly that is running each one of these. So Ubicorn will have to be on top of everything. But anyway, this just gets some random noise. But the thing is that we are getting on the ballpark of the best that we can get with Python. And in this case, as you can see, we have been able to serve 15,000 requests per second or something like that. So this is over 9,000 requests, which is quite good. And now, why is it that FastAPI can have this performance? FastAPI doesn't do anything smart or anything complicated underneath, but it uses libraries that do very smart things. So Starlet is the thing that does all the web parts. Pydantic does all the data validation parts. Pydantic is built with Python, which is compiled with Python, which is this sort of compiled Python language. So Python allows taking like all the power of C inside of Python. And Pydantic is built with Python, so this gives it like very high performance. Then Starlet is run with Ubicorn. Ubicorn is what implements that specification to communicate with async and await with web in Python. And Ubicorn uses UVLoop, which is this high-performance async IO drop-in replacement. And UVLoop uses Python underneath. So this, in the end, is what gives all this additional performance. It's just that it's using those tools to power things underneath. So FastAPI has high performance in terms of concurrency and throughput just because it's built with high-performance projects underneath. Now, some of the people behind these tools: Tom Christie, again, he's the creator of Starlet, Ubicorn, HTTPX, and a bunch of other things. Yuri Silivanov is the creator of UVLoop. He's also the creator of async and await inside of Python. He added those keywords to Python itself. And he's the maintainer of Python. So again, just like normal people that are maintaining these projects so we can benefit from their work. Now, I have been showing you a bunch of these normal people that are just like, just like people that work a lot and are building these projects for others to use. This is, and I wanted to emphasize this about the community. Most of that work is done during free time of these developers that are just like trying to help others. In most of the cases, it's just like people doing it for free in their free time, just trying to help others. In many cases, these maintainers of these open source projects might have hobbies, but in many cases, they just cannot work a lot of them because they just have these open source things that they have to do. But you can help too. For example, with FastAPI, you could translate a page. This is something that not everyone can do because not many people speak more than one language. But if you speak English and another language, you will help translate the page, and that will also make it more accessible to people that speak whatever is that other language that you can speak. You can review the translations from others, you can answer questions from others, you can help with bugs and features, or you can also help with other of the projects that you are using. something that you can do is whatever is the project that you are using, whatever open source project you are using, you can go and check like how can you help. In many cases, you can just like fix a little typo in the documentation, and that's already helping. And yeah, that's what I had for you. Maybe we can check some questions. I don't know. Let me see if we have some time. I think we are right on time. Thank you very much
Thank
for
you
having
very
me.
much. Thank you very much, Sebastian. I think that was a very great talk. A lot of information condensed in your talk, and we actually have a lot of questions already. The audience love your talk, and they've been interacting in our other platform. So maybe I
Nice.
can
Sounds
pick some of the questions, Sebastian. Maybe you can help answer.
perfect. Yeah, sounds
Okay,
perfect.
sure. So we have this one first, I think, from Hardeva Rogonondo. Let me read it out for you because it's quite long. So I've used a lot of Python web framework in this past year, and I found out that FastAPI is indeed the fastest web framework in Python. But sometimes when we build our projects into Docker image to be deployed, the project that use FastAPI tends to be built into a bigger uh, images, right? Is there any plan, or what is your thoughts on this? And is there any plan to make it smaller in terms of the deployment?
Yes. So, well, the first thing is if you are using the official Docker image, the official Docker image is for very simple cases. And if you are using Docker, there's a high chance that you use something like Kubernetes. In that case, check the documentation, the new documentation about deployments with FastAPI that explains like when to use that official Docker image. Because if you are using Kubernetes or something like that, that it already takes care of replication of containers and all that stuff, then you might not want to use the official Docker image and instead use Docker image built from scratch and just install Ubicore and install FastAPI directly on it. With Python, whenever you're installing packages that depend on extensions from C and all that stuff, you might end up needing to have like this additional space that is consumed by those libraries. FastAPI itself doesn't require that much. Like FastAPI itself is just like I don't know some kilobytes, some megabytes, and it doesn't have like any strong dependencies. But if you have another dependency, like a bunch of dependencies in your project that might be very heavy, then that might consume a lot of the space in the final Docker image. The other thing that you can try is the slim images to build the package. Something that you will probably not want to do is to use Alpine. So Alpine in many cases is said to be like very slim and stuff like that. But the thing is that Alpine doesn't work well with Python because it doesn't work well with the standard C libraries that Python with extensions will use. So you are probably better with the slim versions of the images if you are concerned about the size of the Docker images.
Okay, thank you for the answer. Okay. We also have a lot of other questions, so maybe let me actually pick some other question. This one maybe.
Perfect.
This is quite interesting. From Alvin Frayuda Juniarta Dwiantoro. Is there any best practices if we want to integrate a WSG app with Fast API, like Dash or Plotly?
Yeah, so WSGI, for those that might not know, WSGI is the previous standard for communicating, for building web applications with Python. The new standard is ASGI, which is async and await. And WSGI will be, for example, Flask or Django or most of the other frameworks. ASGI is like, things like FastAPI or some of these new frameworks. Something, if you want to use Dash or Plotly that depend on WSGI, well, one thing that you might do that might be the simplest thing is to deploy them independently of whatever is the API that you're building, because like they already have like their own package that you just run directly. The other thing that you can do is that you can mount WSGI applications inside of FastAPI. And there's documentation for how to mount, for example, Flask inside of FastAPI. So that's something that you can do, and it's something that is already supported, and you can mount it there directly if you want to have like a single server and a single application.
Ah, okay. Cool. Cool. And next we also got one from Yahya Fadullah Al-Fati. I think he is already using FastAPI for 2 years, and then I think encountered some problem during debugging, right? Do you have any alternative debugging besides the FastAPI tutorial? Like maybe best practices or something that you usually do for complex application?
Yeah, so for debugging, when you're running, for example, with Visual Studio Code, you can run, there's now there's actually like a quick option to debug something that is a FastAPI application. And you can just start the server directly with this configuration so that you can start Ubicorn using FastAPI directly. The same with Python, there's an easy way to start at the debugging session. Uh, I don't know what will be the absurd error. I
Maybe it's
guess,
maybe it's related to like debugging asynchronous application or something. Is there
yeah, I don't
any?
know.
Okay,
I don't know what might be like the specific use case. But the thing
okay,
is that if you run it through the debugger, then you will be able to see like all the information, and like they actually like these debuggers have actually very good support for how to interact with these things, even with different threads and everything, and they actually can do a very good job. On the other side, there are some particular errors, for example, validation errors of the responses that I want to improve how the error is shown in the backend, so that whenever you see, oh, I have an error in my code, it's easier to spot exactly where is the error in your code. That's something that I want to work on, that I hope I will get to build at some point soon. If that is the case, but yeah, otherwise you can also like check in the questions in the GitHub issues.
okay. Uh, you also mentioned during your talk about maintaining open source project, especially one as large as this, right? We have this question. Oh, sorry, let me close this one. We have this question from David. So, what is the future of FastAPI that you're envisioning? Are you planning to actually appoint a co-maintainer with you, or maybe you're planning to make it into a community-driven project like Flask, or make a foundation like Django? Do you have some thoughts on that on the future of FastAPI?
So yeah, so a community project like Flask is actually maintained mainly by one person. Even when these projects are in one organization in GitHub, in most of the cases, there's just like one or two people that are actually working a lot on them. For example, Starlet, that is created by Tom Christie. He's also the creator of Django REST framework, and you can see that they are on their own organization, but it's actually just him. It's mainly him. So the difference is mainly where the repository is located. If it's in an organization in GitHub, or if it's in the personal account of someone, but it doesn't really change anything. It's still the same person that has like the control of that repository. In my case, I don't have like a lot of benefit from moving FastAPI somewhere else, because I'm still doing like most of the work. I still review each one of the pull requests, and the thing is, if you check the history of the pull requests in FastAPI, it's almost none of the pull requests are accepted directly without any changes. In most of the cases, I do a lot of changes on top, updating little things and improving little things, or maybe refactoring some of the implementation. So up to now, I have been doing like most of the work and checking that everything is working correctly. And it's also, if you check like the history of commits and everything, like I have done most of the work, so it's not something that I can already just like move somewhere else, and like I cannot simply give permissions to other people to just randomly merge other pull requests, because I still review all of them. So for now, I will keep it as that, because that's what has worked up to now, and I want to build the best thing that I can with this tool, with all the ideas and all the features that I want to implement. Maybe later at some future, I don't know. But yeah, for now, I will just keep it like this.
Nice, nice. And I think the community is thanking you for all the works that you've done. I know that everyone, like a lot of people, are actually already using this project, right? Um,
Thank you.
so- yeah. We have this one from Danang now, Danang Wibisono. Uh, how accurate should we give type hints? Like, for example, when you are doing nested dictionary, I think it's usually a problem when you're having application with nested dictionary, right? Do you use any, or how accurate would you want the type to be for those scenario?
So it actually depends on your application. If you use any, then Python will receive anything there. And the thing is, whenever you are using that inside of your code, you will have to check manually, like, what is this thing? Is this a list? Is this a dictionary? Is this a string? But when you declare what is the type that you expect, then your code is a lot easier to write, because you know, oh, this is a string, then I can have auto completion for strings. I can make it uppercase. I can, I don't know, I can split this string. You can do like all the stuff that you can do with a string. So when you add more specific type hints to your code, you're actually making your future work a lot easier. Whenever you're declaring the shape of data from JSON requests, I would recommend like trying to declare it as explicit as you can. I'm not saying, for example, any using the type any in those declarations in the Pydantic models, for example, because then you could receive a bunch of data that is not cleaned, that might have invalid information, that might have errors. That then, for example, if you save it to the database and then you read it somewhere else, assuming that it will have some shape, but then it doesn't have the shape, it will break your application. So this data validation is actually just to help your future self. That is the main purpose of that. Also, with the type hints, you get you get the validation, data conversion, and documentation, automatic documentation in the interactive API documentation that you get. But also, because this is based on Open API, so you get this standard that you can extract and work with it. There's a bunch of tools that you can use to generate automatic client code in a bunch of different languages. So you can create a client for your backend within TypeScript, for example, that we have all the information of these type annotations. So people writing front end in TypeScript will be able to get auto completion in their client, in their code for the things that you declared in the backend. And this works if you have the type annotations. If you don't, then none of that will work. So for simple cases, you can just like use any, whatever you want. It's just that at some point you will end up needing to know what is the information that is inside of that anything and that any type or that any parameter. And then in those cases, you will probably want to have more strict or more explicit type annotations.
Great. Okay. I think we're running out of time. And once again, I want to say thank you on behalf of everyone and the organizers, Sebastian. So thank you very much for, flying all the way to Indonesia and, speak with us. And hopefully we can actually meet you in person in the future edition.
That would be amazing. Thank you very much. Thank you very much for
Okay.
inviting me. Thank you very much for having. Have a great rest of the day.
Yep. Yep. Let me call Dima to the stream. Dima, can we close the session? You're still on mute, by the way.
We
We
can
cannot.
we
We
can't
still
hear
cannot hear
you.
you.
You muted
Oh, okay. Maybe there's an issue maybe with
with
Dima's
the audio maybe.
microphone. Yeah, we cannot hear you, Dima.
Hello. Okay.
Now we
Thank
can
you.
Ah,
hear
okay.
you.
Nice.
Okay. Sorry. Okay, I was on mute. Thank you so much for Mas Gio and also Sebastian Ramirez. Thank you for coming to PyCon Indonesia 2021. We really hope that you can meet us in persons, but this is the COVID time. So thank you so much. Maybe we can meet in other time and other place. See you.
Thank you very much.
Everyone.
Bye. Thank you for the invitation.